Here I want to do an analysis of the benzoin we produced and show you the quality of crystals that we formed. So this is the Loran oils reaction to form benzoin, and the product is this has this appearance here, so you can take a look at that. Spindly, flaky, whatever you want to call that. It's fairly white, and I prepared a melting point tube for that, and it's going to be the left tube in the melting point apparatus. Here on the right, you can see the color is significantly more yellow, and it does have an off odor. It's really hard to explain. And I've prepared a melting point capillary tube of this substance as well. So this is the Traverse Bay sample, okay? And so I'm going to go ahead and load the microcapillary tubes into this melting point apparatus, take a picture with my phone at the same time that I'm recording the temperature. Okay, so I've put the samples in. The left sample is the Loran oil sample, and the middle sample is the Traverse Bay body and bath. And the temperature there you can see on the video is about 110 degrees. Okay. So kind of hard to see these samples, but you can see how they are translucent or maybe opaque. And so we're going to go ahead and set the dial here a little higher and let this melt. Okay. Now this is the crude material and it's uncrystallized, so the melting point might be higher than we would lower than we would expect, and perhaps even broader. But remember that melting point's always a range, so you want to record the initial temperature at which it begins melting and the final temperature at which it completely melts. Once again, the sample on the left is the Loran oils. The sample in the middle is the Traverse Bay sample. These are not guaranteed to melt at the same rate or at the same temperature because they are different purities from different sources of material. So you heat the rate up a little bit more here. I think the literature melting point is above 120 or 130 or something, so we got to get this moving along here to get a reading. Looks like it's compacting, but I wouldn't say it's melting necessarily just yet. Looks like the one on the left might be melting now. Not sure. bottom of the tube still look solid there, so photo is not the best here, but we'll do our best for this virtual lab. Seems to be in focus when I hold the tubes higher up, so it's hard to see it when they're down because of all the lenses involved here. There's a magnifying lens in front of the viewport, and there's also the lens of my camera, so yep. Let me try to get the rate heating up just a tad bit more. Want to look for something that looks like melting snow, and remember that the final temperature that you should record is when it looks fairly homogeneous and looks like water. One technique to rewatch this video would be to restart the video and watch it at a ×2 speed. That might help you decide when it first started melting and when it ended melting. Okay. All right, so I'm going to go ahead and stop the video now. So once again, the sample on the left here that I'm raising and removing is the Loran oils. And the sample in the middle is the Traverse Bay that I'm now removing. I'm here to weigh the products that we produced. So we've got the first off here, the Loran Oils product. Okay, it's got LO on the watch glass. And I'm gonna bring you over here and put this on the balance that's zeroed. And remember that this is the weight of the watch glass and the crystals. So don't forget to subtract the weight of the empty watch glass. So this is the Loran Oils reaction. The Traverse Bay reaction, as you recall, it's that more yellowish color there. And here's the mass of the watch glass and the crude material. Okay. So that concludes the lab. Thanks for watching how commercially available benzaldehyde substances from various oils purchased off of eBay could be used for the benzoin condensation. Thanks for watching.